Hello everyone, it's Peter. Welcome you back. So this class I will cover design patterns. So in the interview, I think the most frequent interview question is about the singleton because this design pattern will cover lots of other basic OOP concepts. So I will focus on singleton pattern and other patterns including the GOF pattern. GOF pattern is a group of design patterns like GAN04, and I will leave you one homework to design the interpreter pattern. Right. So I will list some patterns, and if you have interest, you can go through all the design patterns. But to face the interview, I strongly suggest you to clarify, to make clear of every details of a singleton pattern. We talk about the prototype, right? And the prototype is a shallow copy of object, and singleton means that there's only one object. It's a singleton. Okay? No matter how many times you call it's only one object. So now let's write a singleton pattern. Okay, new package java.pattern. So I new a class my singleton. Now we can think about before we write this class, we need to think about how to write a singleton. Because the singleton has only one object, so we must guarantee that its constructor must be private. If the constructor is not private, I can call this constructor, then I can create many objects. So I need to have a private constructor. Okay, my singleton. For test purpose, I print out a line for test purpose. Create an object of my singleton. That's a private constructor. Now, after that, let's think about that. At least we should have one instance, right? We need to define instance. If we define instance inside this singleton pattern, but we don't have a constructor, how do we call it? Then we cannot call it, right? Because we cannot new it. So the only way we can use an object is that we have to make this object as a static. Because static is class level, it means that I don't have to new it, right? I don't have to new the my singleton. I can touch the static variable, right? So I talk about then we create a static method, I have to make it as a static. My singleton as an instance. Why I use private? If it's not private, then I can use public. I can access it directly, then I can change it. But I don't want to change it, right? Because there's only one object. So including this private static variable, I need to provide a static method because currently I cannot use any non-static to make this object because I cannot new it. Right? So all I used is the static level. So I need to provide a public static method, say my singleton, get instance. Okay. So we can check if instance equal to null. If it's equal to null, I create a new my singleton. Because this is a private constructor, I can only access private constructor inside the class definition itself. And then I return instance. Right. I return instance. So in this way, we finished my singleton class. And for other part, you can do any non-static method. After you create this instance, you can do whatever you like. Right? So we just focus on this part. Why we need to use this if condition? The reason is I can do this here, like new my singleton. But in this way, it means because this is static field, it means that when I load my singleton class into the memory, actually it's on the stack, this object is already created. That's not good because we don't want to create it until you really need it. So that's why I don't create the instance immediately. I want to use lazy loading. Right? So it means that only when I call the get instance, then I can create this instance. Otherwise, I don't create the instance. Right? So I can save the memory. Now after that, let's make a test. Okay. Package Okay, new class, my singleton test. Now, let's make a test. Test one. This is test one. My singleton instance one equals to my singleton dot get instance, and then my singleton instance two equals to my singleton dot get instance. Now assertions dot assert same. Use same. Same means the reference is the same. Instance one and instance two. Okay. Now let's run it. Okay. You can see I only create one instance because every time I call new my singleton, there's a printout. But I called get instance twice, but still there's only once. Means the first time is now, then I create instance. The second time I will return this instance immediately without creating another instance. So you can see this is a way to write a singleton pattern. Looks like very simple, but it contains some basic logic and the basic understanding of the OOP concept. Now, next, I have to ask a question. Is this class thread safe? Is this class thread safe? This is a very tricky question. Because we just mentioned, in the last class, we talked about the multi-threading and the concurrency. So we can think about it. If multiple threads call get instance, what happens? So my conclusion is that this class is not thread safe. So if two threads access get instance, both of them will get inside, and then this condition is false. Then both of them will call new my singleton. But because this is static, there's only one copy, so one instance will be dropped in garbage collection, and one will create it. So how to test it? We will see how many lines will be printed out. Like if this is really a singleton, this created object of singleton, my singleton line will be only once, right? If you have, if you call this constructor many times, it will have many times. So then I make the second test. Void test with multiple thread. Test with multiple thread. Okay. I just say this is as a normal test. Okay. Now I use a for loop. I run. I start the 10 threads. New thread. Then I use lambda function. I just call the start. Okay. Then I call my singleton dot get instance. So it means I use 10 threads to call this get instance. Okay. And to make more specifically, so in this printout, I can add to see which thread create this instance. Thread dot current thread dot get name plus create an instance to see which thread create an object of my singleton. Now I can run this one. You can see there are 10 threads from 1 to 10. 1, 2, 3, 4, 7, 8, 9 create the instance of my singleton. Right? And if you run it again, yeah, there are 8 threads creating the singleton object. So this means it's not thread safe. It only happens at the very beginning. If the first time you call the get instance method, there are multiple threads call this method, then there's a problem. So actually in industry, this rarely happened. It cannot be that That's a coincidence. So the probability of multiple threads to get instance is very, very low. Okay. So in industry, usually this code is good enough. This code is good enough. We don't consider about multi-threading issue, but theoretically, and we need to think about that. Then how do we prevent it to be? How do we prevent it from multiple threads to access it? How do we make sure it is a singleton? Make this thread safe. So one way is use synchronized keyword. Okay. So if you use synchronized keyword, then you run it. So there's always only one. Always only one. Okay. No matter how many times you run it, yeah, it's only one instance. But the bad thing is if you use synchronous keyword, the performance is very bad. The reason is in the future, after you create this instance, in the future there could be multiple threads accessing this instance at any time. Right? So if let's say after you create the instance of this singleton object, there are 100 threads accessing this object to get something. Then, and with synchronized keyword, they only can do one by one, right? Because it's synchronized. The performance is bad. How to solve this issue? So this one we can solve the multi-thread safe issue, but it reached bad performance. Now we have a better solution for that. Okay. Let me give you the real code. I can use synchronized block. Say my singleton dot class. This is a get object of the class level lock. Okay. Then I use the double check. Then I run it. Now let me explain what happens here. Okay, suppose multiple threads get instance at the very beginning. All of them will have this condition to be true. They will enter this inside block. In the inside block, because if they want to enter this synchronized block, they need to get this object lock. This is my singleton.class. This is class level. Actually, this is class level lock. It's a class level lock. So only one thread can inside this synchronized block. So the first thread enters this block and check the instance is now. Yes, it's now. Then they create the instance, and then they jump out. They will release the lock. After the second thread enters, this condition is false. It won't create this one anymore. So based on this structure, it can be guaranteed only one instance is created, right? But after that, after this object is already created, and in the future, multiple threads access the get instance method, and the first condition is already false. So they will move to return instance immediately. So you won't have any performance issue. So multiple threads can get instance and immediately get this instance without because this condition is false. So this is the explanation of the code, and let's test it. Okay. You can run many times. There's always one instance. And I want to emphasize that in industry, it's not recommended to write this code. The beginning the code, like if instance equal to null and you create instance, that's good enough. So it rarely happened that at the very beginning multiple threads call get instance. So if you go to the SonarQube, which is a code analysis tool, it will show some warning. So it's not recommended to use this kind of code. This is about singleton. So for singleton, it will combine lots of concepts like multi-threading, the different levels of synchronization, right? And to compromise with the performance and the thread safe, right? So they cover both. It has good performance and it is also thread safe. So sometimes there's a very good strategy to make a good performance and also thread safe. And when we talk about this, then we can come back to an API. Is in let's talk about in the collection framework. We talk about the same map, right? Value pairs. So, like concurrent hash map. Concurrent hash map. This is uh, okay. This concurrent hash map has both thread safe and good performance. And there's a hash table. Oh, here I didn't mention about the. I only mentioned about the linked hash map, which is keep the insertion order, and the weak hash map, concurrent hash map. Well, I should have one more. Okay. Let's make up of this one. There's an API called hash table. Hash table is thread safe, and hash map is not thread safe because usually we don't use the hash table. Hash table has worse performance. So usually in industry, either we use hash map. That's good. And if you care about thread safe issue, we use concurrent hash map because concurrent hash map can do both thread safe and good performance. The performance is not as good as hash map, but it's already very good. But the hash table has better performance. Has better performance. So I just mentioned here. I don't know if in the current industry people still ask a question about the difference between hash map or hash table. But as per my experience, we never use hash table. We never use hash table because we already have a very good one as a replacement. It's called concurrent hash map. So this one covers both thread safe and performance issue. Now let's come back. This is about Singleton. Then decorate and facade. Facade is everywhere, like collection framework. This is a facade. There's a top level interface, like a collection or list or set, and all the implementation is hidden behind. This is a facade, very simple. And what is decorator? Decorator is a mapper. It's a mapper. A good example of decorator is our file IO. This one. Not here. File input and output. Okay. So if you see our code in IO, okay, so you can see there's a file input stream and the object input stream. They are all belonging to the same input stream family, and one wrap the other. So sometimes the decorator is also called a wrapper. Okay. So file IO, input output, input stream output stream is a good example of the decorator. It's a good example of decorator, and there are some behavioral design pattern like observer pattern, command pattern, strategy pattern, interpreter pattern. So here I give you lab 5 as an interpreter. The example is here. Let's go to the lab. So in the interpreter. So I want you to do the expression parser. We talk about the recursive way to do the expression parser, right? I already give you the code, but now I want you to use a different way, which is interpreter. We have a parser, okay? Parser to parse an expression, okay? Now this expression is a top-level interface. It has parse method, and then I have a parser to parse expression. So I use constructor to get this expression, and I call the parse method. Then this is your code. So in this way, I can give you a hint. You can define different parsers, like you can have add parser. Add parser to have two different expressions as input, and to parse them and parse them. You have add expression, add parser. This is general parser, and you can also have add parser to implement the expression. You can have subtract parser to make two expressions subtract. You can have multiply parser, and you can have divide parser. And then the code is very similar to our recursive code, but it's not calling recursively. They just call different parsers. So if you have parse sign, you can call add parser. If you have a negative sign, minus sign, you can call subtract parser. If you have the star, like the multiplication sign, you can call the multiply parser. If you have divide sign, you can have the divide parser. So the way is very similar in this code. If there's no plus minus multiplication or divide sign, then you just pass it as a double the pass double, right, to get it. Okay, this is about the interpreter pattern as your homework. And here I also mentioned another design pattern in the GOF. This is a template pattern. Village pattern is also very important. So if you have interest, you can make research by yourself to understand design pattern. It will take a long time for the design patterns. Template pattern, the good thing for template pattern is this is a good example to use the abstract class. So in our code, we use lots of interface, but not much about the abstract class. Actually, there are some abstract classes, like in the file input output, the top level, like input stream, out stream, they are abstract class. Okay, and another example in template in template method, this means that the top level is an abstract class, and you have different subclasses. For example, like a game, you can define a top level. Maybe I can write it here. You can have abstract class game. Okay. In this game, you can define some abstract method. For example, you can have abstract as a public abstract void initial game, right? And you can have public abstract maybe this in the abstract class you can also define concrete method. For example, you can say make a move. Okay, you can make a move. Oh, sorry. Okay, let's just say abstract. Void or main. The return type you can move one step, and then you can make a abstract like boolean is finished, to tell it if it is finished, and then you can have a method called play. In the play, usually you first call init, while not finished. You can call this method. If it's not finished, you just move. Something like this, you just move. And after you finish, you can claim the winner of the game. Okay? So this is normal game. You initialize the game and you make a move, then you check who is the winner. If the game is finished, if not finished, you can move again. And then you can have any other game like a class, like a chess game, extends game. And then you need to override those init method, or even you override the play, or you just call the play method. Or you can run any game, or you can play dice. You can like play dice, and player 1 play dice, player 2 play dice, and then to compare their point. If one is bigger than the other, then it's finished, is claim the winner. If it's a tie, then you play the game again. So you can try this kind of game and finish those methods. This is a template method. So it means that the top level abstract class is a template. And based on this template, you can define what the exact game you want to play. Okay, this is a template method. I don't want to spend much time to go very deep. And if you like, you can visit Wikipedia or some other website to go through the GOF patterns. Okay, so I think that's all for today's class. And it's also the end of the advanced Java programming. So in this advanced Java programming, we will cover more on conceptualized about Java, OOP concept, collection framework, exception handling, file input output, is multi-threading concurrency, and the design pattern. There are not much complicated logics, but there are lots of concepts, and I think they are very, very useful in your interview if you want to get a job. So those concepts must be very clear in the interview. And from next class, I will start the Spring framework and Spring Boot. Okay, and then we will introduce the logics, the concepts, and lots of hands-ons. Thank you.